In this problem, on the topic of Newton's laws of motion, we are told that a window washer is pulling herself upward using a bucket and pulley apparatus as shown in the figure. We want to know how hard she has to pull downward in order to raise herself at a constant speed. We then are told that if she increases the force by 15%, we want to know her new acceleration. We are told the mass of the person and the bucket to be 72 kg. So the window washer pulls down on the rope with her hands with a tension force Ft, and the rope pulls up on her hands with a tension force which is the same Ft. Now the tension in the rope is also applied at the other end of the rope where it attaches to the bucket, and so there's another force Ft pulling up on the bucket. The bucket washer combination thus has a net force of 2 Ft upwards, as we can see in the free body diagram. Now, we are only showing forces acting on the bucket washer combination and not forces acting by the combination, which includes the pull down on the rope by the person. Now, we can use Newton's second law in the vertical direction, taking up as positive. And so the net force must be 0 if the bucket and washer have a constant speed. So the sum of the forces in the vertical direction is equal to the force Ft plus the second force Ft, both acting on the bucket washer system, minus the weight acting in the opposite direction, m times g. And this must equal to 0. So simply put, this means that 2 times the tension force in the rope must equal the weight of the washer and the bucket. And hence, this force Ft is a half mg. And if we substitute our values into this, we get this to be a half into the mass of the system to be 72 kg times the acceleration due to gravity, 9.8 meters per square second. So calculating, we get this force to be 352.8 newtons, and keeping our significant figures, this becomes 350 newtons. So that's the force that the washer needs to pull on the rope in order to lift herself at constant speed. Now in part B, if the force is increased by 15%, then Ft now becomes 358.2, or 352.8 rather, multiplied by 1.15, which represents a 15% increase. And so the new force at which she pulls herself is 405.72 newtons. Since this force is now greater and her weight stays the same, we can write Newton's second law to find the acceleration. So by Newton's second law, the resultant force, again, is Ft plus Ft minus the weight mg, and this is no longer equal to 0 because there is now a net force, so this must equal to ma. This means that rearranging, we can find the acceleration a to be 2 times this tension Ft minus mg divided by m. Again, we know these values, so we can calculate this acceleration. That's 2 into the new force of 405.72 newtons minus the mass of the system, 72 kg, times the acceleration due to gravity, 9.8 meters per square second, divided by the mass of 72 kg. And so calculating, we get the acceleration now to be 1.47, or keeping significant figures, 1.5 meters per square second.